So here's the solution. I just sketched out the picture if you just wanted a hint. So the hint is that here's our point -4, 0. Here is the point of tangency, which we don't know. I'll just call it x comma root x, right? Because the function is root x, so the y value is root x. And all we know for the point of tangency is that they have the same y value, the line and the curve, and the same slope, the line and the curve. So one of those or both of those will somehow come into play. If you just wanted to hint, pause there, because now I'm going to give the rest of the solution. It turns out that the same y value doesn't really help us here. Sometimes it does, but not in this case. The same slope, that's what we can use, because we have two ways to express the slope of this tangent line. We have the derivative, which the derivative of root x is 1/2 root x. And we also have the difference between these 2 points, right? The change in y, root x minus 0, over the change in x minus -4. So we have two ways to express the exact same quantity, the slope of the tangent line at that point. And so we set them equal to each other. And the x value that makes this true is the x value where the slope of the curve is the slope of this line. And that's our point. So we cross multiply here. And then we solve. X is 4. So that is our point of tangency. X is 4. And now to find the equation of the tangent line, which is what the question wants, we just first off find the point. The point is 4 comma root 4. And we find the slope, which is 1/2 root x, 1/2 root 4. And we put all into an equation. Y equals the y value plus the slope, x minus the x value. And if you have access to a graphing program like Desmos or your calculator, it makes sense to graph this stuff out. Graph the curve, graph the line, make sure that this line does appear to be tangent and pass through that point. It's a nice way to check your work.